Hi, Srini. How
Hi,
was your
sir.
day?
Okay.
Hello?
Yes, hello, hello.
Yes, hi, teacher.
Anything to ask?
Yes, teacher, can straight away go to section B first, section A later. Settle the structure and essay.
You want to go to section B first?
Uh,
Okay. Section B. Right? Not popular question.
oh, not so popular, so can finish everything, lah, sir.
What is it?
No, I mean, yeah, say, discuss everything, lah. Just there's some I can't understand.
Okay, looks like potential divider is popular.
Yeah. Oh, potentiometer not so popular.
Kirchhoff's law and potential divider. These are the popular topic.
Hmm.
Okay, state Kirchhoff's law. You should be able to tell me. 2 mark. 2 laws, 2 mark.
Yes, teacher.
Yeah. What are the 2 laws?
Oh, Kirchhoff's first law and second law.
Yeah. What is it? Yeah.
Wait, no, they said state board.
What's the first law?
Kirchhoff's first law is the algebraic sum of the currents entering a point in the circuit is 0.
Okay, algebraic
That's
sum of current into a junction is 0. Okay. Second law?
in a closed loop, the algebraic sum of the product of the current and resistance is equal to the algebraic sum of the EMF in the loop.
Okay, second law states that the closed loop, that's not important. Sum of EMF equals sum of PD. Okay, you should be able to write the equation for me at the junction, at this junction. Kirchhoff's first law, how to apply?
I1 plus I2 equals to I3.
Okay, good. Then take your this loop. What's the equation? Take it anti-clockwise. Yep. Applying a law.
The second equation,
Yeah, I've told show you the loop that I want. This loop. Write me the equation.
Just give me 1 minute, teacher.
Oh, tell me you didn't do your homework.
No. Somebody is calling me, that's why. Hello?
Yeah. Okay. Loop 1.
Yeah, loop 1 is 6 equals to 2I2 minus I1.
Loop 1 lah. Loop 1, not loop 2. Loop 1. This one, this loop. This loop. With the 12 volt there. Okay, got 6.
Yeah.
Yeah, why so long? All this should be doing your homework already, not doing your homework. That's why I say you are going to be in trouble. You come for tuition asking me to do homework for you. It doesn't help you. Yeah. Sum of EMF equals to sum of PD. Drop across the resistor. That's all. Sum of EMF, sum of PD, sum of EMF is in this loop there. There's only one EMF, 12. Then 2 times your I2, and then 6 times your I3. Okay, now give me your, simplify it, divide by 2. Now give me your loop 2.
6 equals to I1 plus 6 I3.
I1 plus
I6 no 6 equals to I1 plus 2 I2.
they got 2 I2. This is the loop. This is the loop they are looking at. So I1 times 1 is I1, then times your 6 times I3. There's your PD. Right? That's why I say you have not done your homework. You're not revising properly. Okay, no, that's a equation, that's all.
Yeah, I'm okay.
Right? Determine the current in I2. Right? Use a, after that, what are we supposed to do? After that, determine the potential difference across the 6 ohm. Okay, you basically write the equation, that's all, the 3 equations. Play with the 3 equations. Right? Equation 2, equation 3. Replacing I1 in 3 by 1. Right? Take I1 from here to inside here. Right? So you got minus I2, I3 plus 6 I3, 7 I3, and 6 there. Equation 4. So now you can add equation 2 and equation 4 together. Right? Minus I2 and plus I2 is 0, so that is 10. 6 plus 6 is 12. So that gives you your I3 is 1.2 ampere. Right? I2 is, and after that, from equation 2, you can find your I2, because you want to find your I3 afterwards. I2 is 6 minus 3I3. It's up to you which one you want to choose. As long as you can get the 3 equation, you should be able to solve the problem already. Okay, that's your I2, that's why they want. And PD is just your 6 times the I3, that's all. Okay.
Okay.
Anything not clear?
Now clear, Jeff.
Okay, number 2. A battery of EMF epsilon negligible internal resistance is connected to 2 resistors R1, R2 in series. Derive, right? You can just imagine what you're going to do. That's the 2 resistors R1, R2. That's your epsilon naught. Derive the expression for the potential difference across R1. Okay, so there's a current through here. It's just your epsilon divided by R1 plus R2. And PD across that. They just want you to derive the equation for potential difference, that's all. Okay.
Okay.
2 resistors R1 and R2 and a thermistor are connected to a battery of EMF epsilon of negligible internal resistance as shown in the diagram. The EMF of the battery is 6 volt. Resistance of R1 and R2 are 2000 and 5,000 respectively. Explain the changes in the potential difference across R1 as the temperature of the resistor increases. Okay, you should be able to tell me what's happening. Temperature of the thermistor increases. What happened?
The resistance of the thermistor decreases.
Okay, good. Then
Hence, total resistance of R2 and the thermistor decreases. Therefore, potential difference across R1 increases.
okay, good. Right, just use the equation if you want to. Determine the resistance of the thermistor when the PD across R1 is 4 volt. Right, that's your 6 volt, that's your 2000. Yeah, told this is 4 volt. So what should I do? What's the first step?
V1 equals to R1 over R1 plus R2T.
Say again.
V1 equals to R1 over R1 plus R2 times with 6.
How are you going to determine that?
No, the R2T is the unknown lah. R2 is the unknown.
R2 is the unknown, the thermistor also unknown. Right?
Oh,
R2 you know already. R2 is given. R2 is given. Huh? You use the potential divider formula because you consider as combined this one. These two as combined. Right? First calculate, you got a potential difference, you got a resistance, can calculate the current through here. Okay. Then this is 5,000. Right? You know this is 4 volt. So this one must be 2 volt. Across here must be 2 volt. PD across 5,000 is 2 volt. 6 minus 4 is 2 volt. Then you can find the current through R2. Right? So it's 2 volt divided by 5,000. Get that current. Yeah, you know this current. You know this current, I1. You can find a current through the thermistor. I2. Right? I2 is just your, that's your 2. I minus I1, 0.4, 1.6. Then you know the potential difference across here is 2 volt. Then V divided by I, you get a resistance of thermistor. 2 divided by your current. Okay.
okay.
State the function and operation of a potential divider in the electric circuit. Yep, that's the function.
To obtain a fraction of the voltage supplied to the circuit by a given EMF source.
To give a lower PD,
Potential difference.
yeah, lower PD
What's the E?
is
EMF.
the EMF of the cell.
Okay.
To give a lower PD, I think there's something wrong with this.
Yeah, something on the sentence.
Sorry, just let me just rewrite.
Okay.
To give a lower PD, then EMF E of the cell. Okay, or a fraction lah, same thing. Either a fraction or give a lower PD. Idea is to give a lower PD. Operation. What's the operation? How does it work?
It's a formula, teacher.
Right?
V1 equals to R1 over R1 plus
R2 in
R2
series with the cell.
EMF.
Right? And you just take the PD. The PD is tapped across R1 or R2, and is given by the equation. Okay.
Okay.
Light dependent resistor LDR has a minimum resistance of 1000 kilo ohm in bright light as shown in the diagram. LDR is connected in series to resistors, right? There's a 2 kilo ohm. The two are in series, and that is your voltage supply. Determine your voltage VAX. This is across the LDR. Across the LDR in bright light. Okay, what should I do? Yep, what should I do?
Um, 1K over 3K times 9.
Okay,
So that means the R2 is, yeah. So 1 over 3 times with 9.
okay. You can use your potential divider formula. Right? Potential across here divided by 9 is just resistance of this one over these two add together. So you get 3 volt. Good. The light dependent resistor LDR has a minimum 1000.
Actually,
Okay.
their questions is like, I thought it's going to be like super hard, teacher. I mean, look okay only, but like a bit tricky. That's all right. Yeah.
Actually, it's not difficult. Quite straightforward. A and
Need
B,
practice only.
B and C, any multiple choice sometimes can be much more difficult. LDR is connected. Oh, they've done that already. What am I doing? Calculate the resistance R if Vx is 2.75 volt in bright light. Okay. You are told that this is 2 kilo ohm. 5 volt. I'm a bit lost what is happening. Calculate the resistance R. This R. If VAX is 2.75, if the potential difference across the LDR is 275. Right? Just now we calculate we are given that resistance. Okay, now they want you to validate question. Okay, doesn't matter. Let's try what we can do. Right? They don't need to use this one anymore. But it's a bit funny kind of question. Something wrong with the question. You want to find R, they already given you R. So you can find the potential difference across it. Right? Which is 9 minus 2.75. That one is given. So it's 6.25. Then what should I do? Yeah, how to find the resistance R? Yep.
1 over R plus 1 times 9.
1 over R. Huh? How to get the equation? 1 over
No,
R.
no, no. Because we know VAX is actually 2.75 lah, right? So,
Yeah, 2.75.
so 2.75 equals to 100 over R plus 100 times 9.
Yeah, you want to find R, why you make life so difficult for yourself? You want to use potential divider, just use R, divide by 1. Right? And then this one you have calculated at 6.25, divide by 9, that's all. Right? R divided by 1 is the potential difference here. Right? Divided by potential difference across VAX. That's all. Yeah, that's happening. Okay or not?
Okay.
Funny type of question because R is already given you here already.
Yeah, it's a kind of funny question, sir.
Something is wrong with the question. Okay, what matter?
Yeah.
Okay. Sometimes it looks a bit weird. That's why I said to you, sometimes it can be a bit weird. It can be the R here.
Then they might give mark, right, teacher, because error or something.
It's up to the examiner to
Examiner.
discuss among themselves. Usually,
Okay.
so that's why I say it can have two different answers. Depend on how you interpret it. Calculate R if VAX is 2.75. This is 2.75. They want to find this R. Okay, just now we find this R, right? Depend on how you interpret the question. So if I interpret the R for this one, then my VAX is 2.75. I calculate the same thing. Right? This one, I got that. Then I can find the current through it. Right? Again, as I say, you can use potential divider formula faster. R divided by 2 is 275. R is this one. This is the R that we are want to find. R divided by 2 is this 275 divided by 6.25, which is this one. Right? Or if you forgotten the formula, you can calculate the current first. Okay, something wrong with the equation. Anyway, if you combine section C and section B, you can see that certain years it doesn't come out at all. You can see that. Certain years it doesn't come out at all. Not popular, does not come out every year. Okay, we won't bother about that already. We have done that already. Okay, as usual, you are given 2 ohm, 6 ohm, 1 ohm connected to 2 batteries. These are your 2 batteries shown in the diagram below. Write down the 3 equations. Okay, at the junction here, what's the first equation? Yep.
First equation.
Yep. First equation is Kirchhoff's current law relating the 3 current at this junction.
12 plus 6.
First equation, current, Kirchhoff's current law.
First
Kirchhoff's
equation.
current law.
6 equals to
What 6 are? Current. How are the current related to each other? That's the first step. How does these 3 current related to each other?
I1 plus I2 equals to I3.
That's your first step. Okay. Then loop 1. What am I doing? Okay. I didn't do it properly. Okay, if we take this loop, clockwise. This loop. What's the equation? Yeah.
Which
Kirchhoff's
loop?
voltage law. If we take the top loop, this one is 12, 2 times I2, 6 times I3. Okay. Then you can simplify it, divide by 2, divide by 12, this is 6, divide by 2 is 1, by 3, divide by 2 is 3. Okay, if you take this loop, you should be able to tell me the equation. Trini, you have to do your homework. If not, you're not going to do well in the exam. Right? You come for tuition, you don't do your homework, you are going to lose out. Wasting money, that's all.
The second one is 6 equals to I1 plus 6 I3.
Okay. Right? After that, you are asked to determine I2. It's just your math problem. As long as you can get the 3 equation, then there's a math problem. Just replace this replace the I1 here, or replace the I3, whichever you want to. Right? From 3 and I1. I replace my I1 here. So I take my I3 minus I2. So I get my I2 here. Right? I3 plus that is 6. So after that, 2 plus 4. 2 plus 4, I can carry my I2. I get 10. Right? This is done before. Okay. Then you can calculate your I2. After calculate I3, go to from equation 2. That's the equation 2. I2 is I6 minus I3. Put in your value and calculate out. Okay. Determine the potential difference. I think we have done this before. I don't know why you keep on repeating. Okay, let's go to number 2. Describe the potential divider as a source of variable voltage. Yep. Describe.
I have to draw the thing larger.
Yeah. Draw the picture like what it is called here, and then describe. Right? Potential divider is made out of a cell in series with 2 resistors.
EMF of an battery, fixed resistor, variable resistor.
Doesn't have to be variable. Right? You just tap your PD from one of the resistor, that's all. Okay, a battery 12 volt and negligible internal resistance is connected to 3 resistors. R1, R2, R3. If the resistors value are given 5, 10, and 5 kilo ohm, calculate the output. Okay, how to calculate the output across R2? How to do that? Across this RL. Right? Combine these two together to find one resistor, then become a potential divider. Right? Replace that. And your V out is there. So replace that. This is your 12 volt. This is your 5. Replace these two. Calculate out. You can calculate your own way. 1 over 10 plus 1 over 5. Add them out and then take the reciprocal or use that. Calculate there. Your R, that's your R. And use your potential divider formula. Right? R over the combined times 12. Okay.
Okay.
Current through R1, R2, and RL. Huh? So in a sense, they are testing it Kirchhoff's law also, not potential divider. So okay, your V we have already got 4.8 volt. Then you know the resistance, you can calculate the current to each of them, or you can calculate the PD across here. Right? It's just 12 minus that V there. That's why we get 7.2 across here. Then just a matter of using I equals to V over R1. V we already know. V1 is no. R1 we already know. Put in your value, calculate out. Then through here, I2, same thing. We take the voltage across V divided by R2. Voltage across, we already calculated out, 4.8. That one there. Divided by 10K. And after that, the same thing. V divided by RL. 0.96. Power dissipated at RL. Continue to remember the formula, that's all. I square R. Then put in your value. Convert it to ampere. Square that times your R. R is 5 kilo ohm. So it's 4.61 milliwatt. Okay. Any comment?
Okay. No, teacher.
Right? They try to combine now. Potential divider. Circuit consists of a uniform slide wire XY. That's your XY. 2 cell. That's your 2 cell. Negligible internal resistance. E1 and E2. Two identical resistors. R. That's your R. And 2 switches. That's your R and that's your R there. And 2 switches. Right? That's your S2, that's your S1. And a galvanometer, that's your galvanometer as shown. The length of XY, 100 cm, the resistors 3 ohm. If the EMF E1 and E2 are 2 and 1.5, 1.3, sorry, this is 2, this is 1.3 respectively, and the resistance R is 0.5 ohm. Determine the balance length of XJ. What do I do? Yeah, what do I do?
What's that? I over V equals to I over V. We just do the comparison thing, sir.
I over V? How where do you get the I and V?
No, they say both S1 and S2 open. So yeah,
Okay, both S1 and
yeah,
S2 open.
V 1.3 divided by 2 equals to
1.3 divided by 2.
current of XJ over 100. Yeah.
Cannot do like that. Right?
Yeah, that's what I said, sir.
XJ over 100.
Yeah.
1.3. S1 and S2 are close. Sorry, S1 and S2 are close. This is close.
Yes.
So you can throw this away already if it's close. S2 is also closed. So you can throw this away already. Right? So basically you're measuring the EMF. Okay, so Xj over the 100 equals to your you take Xj, so you have to take 1.3 over 2 and calculate out 65 cm. X1 is open and X2 is closed. S1 is open, S2 is closed. So X1 is open. What's the balance length? How are we going to calculate that? Yep. Yep. Tim, calculate again, that's all. Calculate again, that's all. Right? You have to calculate your Vxy. Right? Vxy over 2 over this one is your 3 ohm. Right? The resistance is 3 ohm over 3 plus this one is a potential divider. Right? You want to find a potential across here, the wire. Right? Calculate your Vxy is 1.17. Right? Yeah, just repeating the question. That one there, previously we can use this 2 volt, but where we are using that resistor, you cannot use anymore. You have to find the potential across here. That's what we are doing. Then after that, repeat the question again. Xj over 100 is 1.3 over this one. Potential across xy is 1.17. And calculate out. Can.
Can.
Okay, I think we take 5 minutes break and then we will go to a new Zoom.
Can, teacher? Can. Okay. Thank you.
Okay, take a break.
Okay.